So, last class we studied lots of chemistry and the chemical reactions. So, today we have started again and we try to learn more and more concept inside the chemistry. So, let us start the class. So, question number 69 is on your screen. So, iron carbonyl FeCO whole 5 is. So, they are giving tetranuclear, trinuclear, mononuclear and dinuclear. So, what are those? So, number of metal atom attached. If I am directly go to the solution part, if one metal atom is attached, then that is called mononuclear, because one mono terminology is come for one. Now, if attached is 2, then it is coming as di. If metal atom is attached 3, then it is coming as tri. So, like that it is going on. So, if you see in this your coordination compound, that is tetracarbonyl ferrate, it having only one metal atom attached, that is iron. So, if one is attached, then what is this? Mono. So, if you see option number 3 is a mononuclear. Okay. So, that option number 3 is the correct answer of question number 69. If they are giving like Fe2CO whole 5 and they ask you the what are the tetranuclear, trinuclear, mononuclear or dinuclear. So, if you see in this example 2 metal atom is attached, so that is a dinuclear example. Okay. So, just check the number of metal atom is attached. If 1, then mono, 2 di, 3 is there tri, 4 is there tetra. So, this is the solution of question number 69. Now, we are moving to the another question, that is question number 70. So, question number 70 is on your screen. So, match the metal ions given in column 1 with the spin magnetic moments of the ions given in column 2 and assign the correct code. So, we are moving to the solution directly. So, if you see, so they ask about the spin magnetic moments. Okay. So, what is the formula? So, the formula is nothing but n plus 2. Okay. So, this is the formula, and what is n? This is nothing but this is your number of unpaired electrons. Okay. So, this n is nothing but the number of unpaired electrons. Now, if you see the cobalt 3 plus, and when I write the electronic configuration, this is AR3D6. Now, how these unpaired electrons will count? I will just show you one. So, d orbitals having 5 soft shells 1, 2, 3, 4 and 5. So, see number of d 6 electrons will be there. So, 1, 2, 3, 4, 5 and 6. So, how many unpaired? 1, 2, 3, 4. So, 4 unpaired electrons will be there. Similarly, for this argon it is coming as 1, 2, 3, 4 and 5. So, 1, 2 and 3. So, 3 unpaired electron. For this 1, 2, 3, 4 and 5. So, 1, 2, 3, 4 and 5. So, 5 unpaired electron. For nickel 1, 2, 3, 4 and 5. So, how many? 8 electrons will be there. So, 1, 2, 3, 4, 5, 6, 7 and 8. So, how many left it out? 2. So, 2 unpaired electrons. Now, when we put this formula with this with the unpaired electrons, we will end up with this result 24, 15, 35, 8. I will show you one. So, for cobalt, what is the unpaired electron value? That is 4. So, root over 4 plus 2. So, 4 plus 2 is 6 and 6 plus 4 is your 6 into 4 is 24. Okay. So, this 24 will come. Now, see for this one also I will show you. So, unpaired electron is 3. So, 3 plus 2 into 3 root over 15. So, in this way we are calculating this magnetic moments value. Now, just match the magnetic moments value. So, sir, nickel 2 plus is showing root over 18. So, D is goes to 1. Now, another one is Fe2 plus Fe3 plus is showing root over 35. So, see, for color differentiation Fe3 plus is showing root over 35. Now, if you see your chromin, it is showing root over 15. So, chromin is showing root over 15. So, where it is 15? This is your 15. Now, another one is given as your cobalt 3 plus. So, cobalt 3 plus is matched with your root over 24. So, just for differentiation I am doing this. Okay. So, as you see the option D match with option 1, option C is matched with option number 2, option B is matched with option number 5 and option A is matched with option number 4. So, this is the answer of this question number 70, and this whole things you will get in the coordination compound, that is in class 12 chapter. So, question number 71 is on the screen. The geometry and the magnetic behavior of the given complex are. So, now we are moving to the solution part. So, if you see, this is the coordination compound. So, here I am writing as coordination compound and short form as CC, and what we found, your coordination number is 4. So, with a coordination number 4, there is a two thing, one is your square planar, another one is your tetrahedral. Now, if you see, according to the VVT, if I draw this one, so nickel NiCO whole 4, okay. So, the nickel oxidation state is 0. Now, if I draw this one, so I am just give you an idea, SC, TV, crewman, FECO, Ni, Ku, Ja. Okay. So, these are the D blocks elements. So, SC, TV, crewman, FECO, Nikuja. So, this is the easiest way to remember. Now, if you see the I am going to write only the D1 and S2 like this. Okay. I am not putting the principal quantum number, because it is easily understandable. Here is coming as 3 and here it will be coming as 4. So, D1, D2, D3, D4, D5, D6, D7, D8, D9 and D10, and here S2, okay, everywhere S2 is present. But if you see the chromium, in case of chromium, this is 4. So, what happen if it gets the 1 electron, so it become D5 and S1. So, for chromium, this is not our electronic configuration, we are getting electronic configuration as D5S1, because this D5 is a half filled orbital and half filled orbital is more stable. Similarly, if you see for this copper, here also if it is take this electron from S orbital, so it get as D10 and S1, and D10 S1 is the high full filled orbital. So, it is more stable structures. So, what you got, we are getting the configuration as D10 and S1. So, this is the electronic configuration of 3D elements. Okay. So, again I am repeating the mnemonics, Se, Tv, crewman, Fe, Ko, Ni, Ku, Ja. Now here it is given as nickel CO whole 4. So remaining all are remove it and just remember the electronic configuration of nickel. Okay. What is this? D8 and S2. So nickel, because nickel oxidation state is 0 here, because if I am putting is X, and for carbon CO we are putting as 0 here. So ultimately the overall oxidation state of nickel is 0. So now what is that question? 3D8 and 4S2, right? This is the electronic configuration. So let us fill the form things, okay. 3D 1, 2, 3, 4, 5 and this is your S and these all are P, okay. So remember this is 3D, this is 4S and this is 4P. So how many electrons are there? 8. So fill it 1, 2, 3, 4, 5, 6, 7 and 8 and here 2 are there. Now one more remember you this one, does this carbonyl or this CO is a strong field ligand, okay. Now here one more thing, that this one is coming, this strong field ligand concept is come from your Vesper theory, not for your this strong field ligand concept will come from the CFT crystal field theory, not for the Vesper theory, but for understanding I am just considering here this is a strong field ligand, okay. So when strong field ligand is there, the pairing take place, okay. So as a result what will happen? The pairing take place 1, 2, 3, 4, 5, 6, 7, 8 and the s orbital whatever is present here, this electron also come to this d orbitals and their pairing take place and here s and we are end up with empty p orbitals. So what is the hybridization? Hybridization is coming as sp3. So if sp3 is there, so see the square planar geometry and see there is a no unpaired electrons. Unpaired electrons are not present. So definitely this compound is a diamagnetic compound. So if you see in the options, so it is a square planar geometry and your diamagnetic, yes, this is the correct. Square planar geometry and parametric, no, this is not. Tetrahedral, no. Tetrahedral geometry and parametric, no. So what you left it out? You have to left it out only one option, that is option number 1, which is the correct answer of question number 74. Now we are moving to the next question, that is question number 72. So question number 72 is on your screen. The correct difference between the first and the second order reaction is that. So given options are there 1, 2, 3, 4. So we are directly moving to the solution part. Okay. So here they are told about the first order and your second order. So for first order T half is equal to 0.693 by K, this is for first order, and T half for second order is coming as 1 by K, the initial concentration, that is A naught, and this one is coming for second order. Okay, so these are the equation for T half for first order and T half for second order. Now directly go to the statement. Okay, the rate of the first order reaction does not depend on the reactant of concentration. Yes, that is true. The rate of the second order reaction does depends on the reactant concentration. Okay, that also true. Now if you see, a first order reaction can catalyze a second order reaction cannot be catalyzed. This statement is completely wrong. Now if you see the third option, the half of a first order reaction does not depends on A naught, that is true. Okay, that is true. Half life. The half life of a second order reaction does depends on concentration A naught, that is also true. See here the initial concentration or concentration terms is not there. So this is independent of concentration. but this one is inverse of concentration, okay, means this T half for second order is dependent on the concentration. So, third option is the correct option. Let us see the fourth option what they are given. The rate of the first order reaction does depends on the reactant concentration, the rate of the second order reaction does not. See here they are given as a rate, even if you see in the first equation they are given as rate, but here in the equation or in the question they mention the correct difference between the first and the second order. So, rate is there and rate is there, and rate is both the cases for first order as well as second order. It depends on the reactant as well as the product. Like suppose if I am writing this is the reaction and again if I am writing the rate. So, what will got minus 1 by A dA by dt, similarly minus 1 by B dB by dt and plus 1 by C dC by dt. So, this is the rate of this reaction. So, it is not like that ki rate does not depends on the first order reaction or rate is independent and of the second order reaction. This statement is completely wrong. Okay. So, we have only one statement is left it out, that is option number 3, and which is the correct answer of question number 72. So, question number 73 is on the screen. Among CaH2, BeH2, BaH2, the order of the ionic character is. So, directly we are moving to the solution part. So, if you see these are nothing but these all are alkaline earth metal. Okay. So, what is the mnemonics I teach you for alkaline earth? Beta, Mange, Kanya, Sundar, Bap, Raji. Okay. Now, if you see in down the group, what will happen? The size increases. When size is increases, the valence electron we can easily remove it out. So, I am writing here remove electron more easily. If electron remove is more easy, so what will happen? The metallic character, because metals are nothing but who can lose electrons. Okay. So, the metallic character is also increases, and my friends, if metallic character is increases, the ionic character is also increases. Again I am repeating, down the group if you go size increases, if size will be increases, so it is very easy to remove this valence electron. If very easy to remove this valence electron, the metallic character is increases, because metallic character or metals are those who can easily lose its electrons. If metallic character is increases, the ionic character is also increases, and they ask you the order of ionic character. So, the down groups like this BaH2 is more ionic, then CaH2 and then BeH2. So, here option number 1 is the correct answer of this question number 73. So, next we are moving to the another question, that is question number 74. So, question number 74 is on the screen. In which cases the number of molecules of water is maximum? So, now we are moving to the solution part. So, if you see here 18 ml, and we know that in water case 18 gram or 18 ml is equal to your 18 gram. Now, how should I convert it into mole? So, mole is equal to given weight divided by molecular weight, means 1 mole, and now they asked about the molecule. So, we have to multiply with Na. So, what we get? We are getting Na number of molecules. So, for the first option it is coming as Na. Okay. So, option number 2, if you see, so the 0.00224 liter and it's given as 1 atmosphere. So, how to calculate moles? So, for here 0.00224 is equal to 22.4 liter, and what you obtain, you are getting as 10 to the power minus 4, and this is nothing but this is mole, and they are asking molecules. So, multiply with Na. So, what is this? You are getting as 10 to the power minus 4 into Na. This is the molecule. Similarly, if you calculate for this one, 0.18 gram divided by 18 gram. So, what we will get? You will 18 into 100, 18 will cancel out, 10 to the power minus 2 mole into Na. So, what is the answer? 10 to the power minus 2 into Na. Now, for this 10 to the power minus 3 mole already given, and if I multiply with Na, we are getting the molecules. Now, if you see among all the Na value, that is the Avogadro's value, it having the highest number of molecules, remaining see 10 to the power minus 4, 10 to the power minus 2, 10 to the power minus 3, they are the lower values. So, here they are asking water maximum, molecules of water is maximum. So, which is the option is correct? Option 1 is the correct answer of question number 74. So, next we are moving to the another question, that is question number 75. Question number 75 is on your screen. Consider the change in oxidation state of bromine corresponded to different EMF values as shown in the diagram below. Then the species undergoing disproportionation is. So, now we are moving to the solution part. So, in the question they are asking the which one is go to the disproportionation. So, disproportion is nothing but where the same element or same atom of the same element is go oxidize as well as reduce itself. So, in this reaction if you see this one HBr. So, what is the oxidation state of bromine here? So, here this is plus 1, this is X and this is minus 2 is equal to 0. So, if I find out X is equal to plus 1. So, the oxidation state of Br2 is plus 1. Now, if you see this is the isolated atom. So, here the oxidation state is 0. So, plus 1 to 0 is converted. So, what will happen? This is your reduction process. Now, similarly, if you see here I am putting X here and 3 into 2, that is 6 is equal to minus 1 and X is equal to plus 5. So, plus 1 to plus 5. So, what will happen? The oxidation taking place. So, here the bromine is go to the reduction and in this other process the bromine is go to the oxidation. So, this HBRO, this one acts is as a disproportionation species. So, HBRO is the correct option of this question 75. So, question number 76 is on the screen. The bond dissociation energies of X2, Y2 and XY are in the ratio of 1:0.5:1. Delta H for the formation of XY is minus 200 kilojoule per mole. The bond dissociation energy of X2 will be. So, this is the question from your thermodynamics chapter of class 11. So, now we are moving to the solution part directly. So, if you see they are giving this is the bond dissociation energies ratio. Bond dissociation energies ratio. Okay. So, first write the equation first. Okay. X2 plus Y2 will give you the XY. now maintain the stoichiometric half and half. So, this is the whole chemical reaction. Now, they are saying that, so let us see the bond dissociation energy, let the bond dissociation energy I am writing as Be is x, and this 0.5 I can write as a half into x, and for y it is coming as, for xy it is coming as x, because here also 1 is given. Now, there is a one formula we are using, delta H is nothing but bond dissociation energy of our reactant. Okay, always remember, not product first, here it is coming as reactant, this is make difference from the other delta H. So, bond energy, and this formula is also given on your NCERT booklet. So, minus product. So, this formula we are going to use it here. Now, see delta H value they already given, the given value is minus 200 kilojoule. So, minus 200. If you see in the reactant side, what is given? X into half the stoichiometry. Do not forget to write this stoichiometry. I make it clearly written here. Okay. So, from here I am started, delta H is equal to the binding energy of, or bond dissociation energy of the reactant minus of your product. So, reactant what they given, what is the reaction is half x2 plus half y2 is given as xy. So, this delta H value is already given, that is given as minus 200. Binding energy for reactant, so I already said this is x, half of x and x. So, x into half, this half is nothing but this is the stoichiometry, plus half x into half. Okay. And for product xy, what is given, that is x. Now, solve this one. So, here if I am taking this LCM as 2, so what we have to left it out, sorry, here LCM is 4. So, if it is 4, so 2x will be here and plus here it will be coming as x minus of x. Now, again take this LCM, twice x plus x minus 4x. So, you will end up with x by 4, sorry, minus x by 4, because 2 plus 3 is 3, 3x minus 4x will give you the minus x by 4. So, minus 200 is equal to minus x by 4, minus minus cancel it out, x value we are getting as 800 kilojoule per mole, and which is the option? Option number 2. So, option number 2 is the correct answer of question number 76. Now, we are moving to the another question, that is question number 77. So, question number 77 is on the screen. When initial concentration of the reactant is doubled, the half period of a zero order reaction. So, this question is come from the chemical kinetics chapter of your class 12 NCERT. So, now we are moving to the solution part. Okay. So, they mentioned here the zero order reaction, okay, and they giving you the half life period. Okay. So, we know the T half for zero order reaction is nothing but 1 by 2 K A naught, sorry, T half is equal to A naught by 2k. Okay, if you see here, the T half is directly proportional to A. So, you can write here like this, T half is directly proportional to the A naught, and A naught is nothing but this is the initial concentration. Okay. So, if I am going double this initial concentration, my T half is also double. If I am double T half also, A or A naught, that is the initial concentration, is also doubled. So, what is the answer? Answer number 3 is the correct option, because here they are saying that when initial concentration of reactant is double, because if I am double the reactant concentration A, then T half is also get doubled, and the option number 3 is the correct answer of question number 77.